Hello everyone, my name is Akshay. The title of our paper is Misclassification of Contactless Iris PAD Algorithm. Is it gender bias or environmental conditions? So the agenda of this talk is first I will briefly describe the introduction and give you the brief motivation about this problem statement, and then we will describe the primary contribution and how we have performed this iris presentation attack detection bias study. Then we give you some analysis of the results, and at the end we have also proposed a device algorithm so that the effective iris presentation attack algorithm can be developed. So one of the critical steps in any biometric pipeline, including iris screening system, is the detection of the presentation mediums, including the 3D contact lens based attacks. So recently it is found that the PAD algorithms are also biased towards the gender or demographic variables, but this study was performed using very low amount of data sets, and the dataset was itself very biased towards the male gender. So in this study we have performed a bias study using large scale data sets, and we presented a study to showcase whether it's a gender bias or some environmental conditions are affecting the so the motivation is that if the penetration identity classifier is biased towards any particular gender, then the fake images of one gender will be correctly classified, but the fake images of another gender might bypass the detection algorithms and can give the illegal access to the system. So we want to prevent this kind of bias behavior of the algorithm, so that only the legal person can access the. So primary contribution is we perform the very large scale or authenticated study using a large scale data sets, and we have covered a wide variety of PAD classifier, including multiple pre-trained classifier, and we have trained end-to-end some deep learning classifier, and on top of that we also analyzed the different ML classifier. So we have used two broad categories of deep learning algorithms. One is based on the transfer learning. So we have used BG16, DASNet 50, 152, and DenseNet. And end-to-end, we have trained by DenseNet and LXNet. On top of that, we have also performed the classification using the SPM and the random decision forest. So wide variety of classifier has been chosen to effectively demonstrate whether it's a bias or unbiased. So as we can see in this study, we have used this dataset which contains 81 subjects images, which are like biased towards both the gender, but the existing study is using the 18 subjects images, out of which 14 were male and 4 was female. So you can clearly see the bias comes from this bias dataset itself. So the analysis which we found is that if you're training on one particular gender and testing on another, and or testing on the same gender, that there is a high bias. But if the training data set itself is balanced, then there is a lower chance of bias in the same environmental condition. But the environmental condition is different, then the bias will be there. So like in this out versus out, you can see 80%, 85, 80% accuracy, but in the different environmental condition, the accuracy is 5% higher. Data balance study, we have found that if the dataset itself is biased towards any particular gender, female dominant or male dominant, then the accuracy will be biased towards that particular gender. And if the dataset is biased or not biased, then there is a lower chance of the biasness, especially in the iris presentation error detection. So based on the environmental condition, we found that the bias is coming majorly from the environmental condition, which is maybe the indoor condition or the outdoor conditions. To negligent or mitigate that impact, we have proposed this device algorithm where we combine two classifiers or multiple classifier based on their gender fabric conditions. So once we found that this classifier is biased towards particular gender, we chose that classifier to effectively get the accuracy of particularly high gender. So that's how we are able to improve the accuracy. For more detail, our poster. This is our team.